when we reach D. Alright, so let me start with this here. The expression x minus 2 is a factor of so by so, or is a factor of one of these here. Well, do your writing now. F of x over x minus 2 is equal to f of 2, and see which one has is equal to 0. So just substitute 2 into each one of these things here. Let me check it out. So we have 4 into 2 to the power 4. Take away 2 into 2 squared. Take away 56. 0. So A is the answer one time. The expression that is equal to AB plus 3C minus 3B minus AC. Well, let me just rearrange a little bit. AB minus 3B minus AC plus 3C B into A minus 3 minus C into A minus 3. A minus 3 into B minus C. And we go to go there. A minus 3 into B minus C. So D is the answer. Good day, so here. Which of the following graph best represents f of x is equal to x into 1 minus x? So we know that all x into 1 minus x, this is a negative x squared. That is x take away x squared. So now one time there's a sad face with a maximum point. So it could either be B or D. Next, we check to see where it cuts the x-axis is equal to 0. Again, x is 0. 1 minus x is 0. Move the x across. 1 is equal to x. So at 0 and 1, it cuts the x-axis. So the answer is B. The number of visas issued by an embassy annually is given by V of x is equal to that. The least number of visas issued in a particular year is... Now, this is a question that I really do, up to now I don't understand it, so if anybody have a better explanation for it. The least number of visas issued in the particular year X will be when X is 0, which will give me 72 as the answer. Right, hold on a second for this. Alright. Here. Tra-la-la-la. The roots of the equation are, we'll check b squared minus 4ac now. B squared minus 4ac, I just checking what it is. B is 6 minus 4ac. 36. This becomes plus. Is 5 4s are 20 by 2 is 20 by 2 is 40. So one time I know this is greater than 0. So the roots of the equation are real and distinct. The set of values of x for which that is easy inequality to solve. 5x plus 7 is greater than 10x minus 13. 5x minus 10x sorry, is minus 13 minus 7. Minus 5x is greater than minus 20. X, I'm dividing by a negative number across the inequality, so the inequality sign changes direction. X is less than 4. The range of values of x for which so by so is less than or equal to x squared is, right? So what we can do, we can rearrange this, right? So I have 5x plus 6 is less than or equal to x squared. I'm moving everything on the right hand side. So I've got 0 is less than or equal to x squared. Take away 5x. take away 6. Now if 0 is less than all of this, then all of this will be greater than 0. And if I give you an example, if I have 1 and 10, let me put 3 and 10. 3 is definitely less than 10. If I move the 10 on this side and I move the 3 on this side, I will have to change this inequality direction. 10 is greater than 3. It's the same concept I'm doing down here. I just moving this on this side and I'm moving the 0 on the next side. So I just change the inequality direction. X squared minus 5x minus 6 will be greater than or equal to 0. And I mean, if you're comfortable working here, by all means go ahead and do it. But I mean, I like to do it like this, where I have something is equal to 0, greater than 0, but I have the meat of the expression on the left hand side. Right. Factorize it. I will get x squared, that is minus 6, minus 2 and minus 3, minus 2x minus 3x minus 6 is greater than or equal to 0. X into x minus 2, take away 3 into x minus 2 is greater than or equal to 0. X minus 2 into x minus 3 is greater than or equal to 0. X is equal to 2, or I'll put the sign greater than or equal to 2. It doesn't matter. X is greater than or equal to 3. Now what I want to do here, and this is my way of doing it. I'm going to represent those two numbers on the number line. I have 2 and I have 3. My number line is now separated into 3 parts. The first part is x is strictly less than 2. Here's x is greater than 2, as well as x is less than 3, which means that 2 is less than x and x is less than 3. And here's x is greater than 3. I test in 0. This could be section 1, section 2, and section 3. And I need for everybody who don't understand this method to let me know. I will take note of it and I will make a video on determining the range of solutions for inequalities. I'll make a separate video on that and I will put it on the channel for you to go and watch. So I had to let me know if to make a video on it. So I test in x is equal to 0. In my original inequality, I will have 6. I will do it here since people might understand what's going on. I testing it in the inequality. Plus 6 supposed to be less than or equal to 0 squared. So I get 6 is less than or equal to 0. This is making sense. 0 is and 1. Now I put in statements here for multiple choice. It's not ideal, but I'm still doing it. 0 is in 1 and 1 is not satisfied. So therefore 2 is satisfied. Right, and well, my students go understand what's going on. If you don't understand what's going on, like I say, let me know in the chat. So 2 is satisfied. So 2 is less than or equal to x is less than or equal to 3. I make a mistake. Minus 2 and minus 3 is minus 5. I make a small mistake earlier. I use the wrong pair of numbers. Concept is the same. Just the wrong pair of numbers I use. It's supposed to be minus 6 and 1. X squared minus 6x plus x minus 6 is greater than or equal to 0. X into x minus 6 plus 1 into x minus 6 is greater than or equal to 0. X minus 6 into x plus 1 is greater than or equal to 0. X minus 6 is greater than or equal to 0. X is greater than or equal to 6. And x plus 1 is greater than or equal to 0. And x is greater than or equal to 1. Same concept. 1 and 6. 1 and 6. So there's 1, 1, 1, 6, 6, 6. Right? So it will still be 2 is the solution. 1 is less than or equal to x is less than or equal to 6. minus 1, sorry. Good, I'm rushing it, man. So D is the answer. Ideally, what you could have done as well, you could have just go and check a value inside of any one of these solutions and get the answer. But I want all to know how to do it, because questions like this does come in paper too. Alright, so let me just go and grab the next piece here now. We do 1 to 7, 8 to 14 now. Jam it in here. Again, this is to avoid any copyright strike and thing from CXC, because as far as I'm concerned, this is just questions I find in some document online. It's not CXC as far as I'm concerned. I don't know. Alright, number 8. If f of x is so by so and f g of x is equal to x, then g of x is easy peasy lemon squeezy. Let y be equal to g of x, because I don't know what g of x is. So f g of x is actually f of y. Substitute y wherever we see x. That is 3y minus 4. So they say that our f g of x is equal to just give me a second. Alright, thank you very much here. Tell me if this improved. Tell me if that improved there. I could ramp it up some more. See that good. Alright, cool. So you go walk with it. Alright. So they say that sorry, f g of x is equal to x. So this fella here is equal to x. So 3y minus 4 is equal to x. I want to figure out what y is, because y is g of x. So 3y is x plus 4 and y is x plus 4 all over 3. So we have x plus 4 all over 3. That is g of x. The tables below show the ordered pairs for two functions f and g. The value of g inverse f of 3 is, alright, so I want to figure out what f of 3 is first. So f of 0 is 7, f of 1 is 5, f of 2 is 3, f of 3 is 2. So I want to calculate g inverse of 2. G inverse of 2 goes from codomain back to domain. So if I have a function g of x governing from domain to codomain, from codomain back to domain, I will use g inverse of x. So I want to figure out what g inverse of 2 is. So I'm looking at the codomain, which is 2. So g inverse of 2 is 5. A function h is defined, h of x is so by so, expressed in terms of h of 2a plus 3. Okay, so h of x is 5x plus 2. So h of 2a plus 3 is 5 into 2a plus 3, which is 10a plus 5 3s are 15. 10a plus 15a. A function f is defined by f is such that x is mapped onto 2x minus 1. The function f squared is defined as, now please, I'm doing this in a different color. F squared of x is not 2x minus 1 all squared. That is wrong. Big wrong. Big X. 0 marks. And I see this question come in paper 2s already. 0 marks. F squared of x is actually f of x, which is f, and I know what f of x is. F of 2x minus 1 Wherever I see x, I put in 2x minus 1. So that is 2 into 2x minus 1 minus 1. That is 4x minus 2 minus 1 and 4x minus 3. Part D. Add the plus 2. For which one, Naveen? Oh yeah, oh shucks. Sorry. I forget the plus 2, that's right. My mistake. Plus 2, 17. I forget that, yes. So that alone should go to show you guys. My mind a little far. That alone should go to show you guys how a question will cater for you making a mistake. So the question catered for me forgetting the 2. So it actually gave me an answer with the mistake made. So yeah, just had to be a little careful, right? So thanks, Naveen. Next, if I zoom, well, I'm going to zoom in on this, not on the document, but on my thing. That is n and m. So this is the nth root of 3 by 27 to the power m. Indices. There is 3 multiplied by 3 to the 3m all to the power n. 1 on n, sorry. 3 to the power 1 plus 3m all to the power 1 over n. Multiply it. So I get 1 plus 3m all over n. 3 to the power 1 plus 3m is the same as 3m plus 1 all over m. Now, if anybody have any questions pertaining to any particular question that we do, let me know. So by so can be expressed as this is just multiplication. 8 plus root 5 into 2 minus root 5 is 8 into 2 minus root 5 plus root 5 into 2 minus root 5. 16 minus 8 root 5 plus 2 root 5, take away 5. 16 minus 5 is 11, minus 8 plus 2 is minus 6 root 5. 11 minus 6 root 5, 8. The value of 2 to the power z, where z is equal to 5 plus log 3 to base 2 is 2 to the power z is equal to 2 to the power 5 plus log of 3 to base 2. Okay, this is equal to 2 to the power 5 multiplied by 2 to the power log of 3 to base 2. Now there is a law, and I don't think it's on the syllabus anymore. The 2 to the power 5 is 32. If I have, and we can check it on a calculator, if I have log 10 to the power log of 3 to base 10, this is equal to 3. And we can check it on the calculator. I have 10 to the power log of 3, that is the base 10, I get 3. So the law states that if I have a to the power log of b to base a, that is equal to b. So I have that I have that occurring here. So this is equal to 3. 2 to the power 5 is 32, right? Let me just double check that. 2 to the power 5 is 32, and I multiply that by 3, I get 96. 15. When this is simplified, it is equal to, so I have root 5 minus 1 over 1 plus root 5. They rationalize something, and it looking like the denominator, it had no roots on it, so they rationalize the denominator, so it's going to be 1 minus root 5 over 1 minus root 5. Bam bam, bam bam, bam bam bam. Root 5 into 1 minus root 5, take away 1 into 1 minus root 5, all over 1 squared, sorry, take away, well, the bottom does always be a difference of 2 squares, root 5 squared. So I end up with a root 5 here, take away 5, take away 1, plus root 5, all over 1 minus 5. Root 5 and root 5 is 2 root 5, take away 6, all over minus 4. 2 into root 5 minus 3, all over minus 4 minus a half, into root 5 minus 3. Well, everything is positive a half, so let's distribute the minus sign inside. A half into 3 minus root 5. D. 2 to the minus 1 over 8 to the power a third simplifies to, lucky thing we have a calculator for the paper 2, paper 1s. 2 to the power minus 1 divided by 8 to the power of 1/3, and we get a quarter. In a geometric progression, each of whose terms is positive, the fifth term is 45, so T5 is 45, and the seventh term is 5. T7 is equal to 5. The sixth term is, we know that our T sub n is AR to the n minus 1. If I have T7, that is AR to the 7 minus 1, which is 6, and T5 is AR to the 4 minus 1, which is 4. 5 minus 1, which is 4. So T7 over T6 is AR to the 6 over AR to the 4. A is cancelled, R is cancelled, and I get R squared on top. So when I calculate the ratio T7 over T6, I will get R squared. Well, T7 over T6 is equal to 5 over 45, which is U and U, nice, 1 over 9. And this is R squared. So R will just be the square root of 1 over 9, which is plus or minus 1/3. And they did say that each of whose term is positive, that means R has to be positive. If R is 1/3 and I have T5, T5 multiplied by a third, which is 45 by a third, will give me T6. Nice, what? 15. And there's a trick for GPs. For GPs, all you have to do is divide terms. A division of terms is a little trick that you want to use in GPs. The sum of the odd integers between 10 and 50 is, now, if you want, we can dissect the question, or we can just make life real easy and just add all the odd integers between 10 and 50. So if I add all the odd integers between 10 and 50, I'm gonna bother to do no big set of working, because I can do this on my calculator. I go have odd integers 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, 49, 598. I missed one. I think I missed one. 11, 13, 15, 17, 19, 21. Oh, I put 22. Okay. It's supposed to be 23. Delete that. Oh, good lord. Delete that. 23 plus. Let me see what I get here. 599. I missed one again. Oh. 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43, wow, 45, okay. Delete, 45, delete, 47, 49, 600, right? Now, because I using my stylus to type them things, that's why I'm gonna make a mistake, eh? Right? Yeah, now see, I'm not reading all the comments there. The first four terms of a convergent geometric progression is given by that. The sum to infinity of this GP is, well, the sum to infinity of a GP is A over 1 minus R if the modulus of R is less than 1. So 500, 200. So R will be 500 over 200. No, 200 over 500, sorry. Yep, which is 2/5. So A, which is 500 over 1 minus 2/5 is 500 divided by 3 over 5 is 500 multiplied by 5 over 3. That's 2500 over 3. D. A long distance runner runs the first kilometer in a race 3 minutes 45, but finds that his speed drops steadily so that each km takes 12 seconds more than the preceding one. The time taken to cover the first 12. Okay. We can't get away from this one. You gotta turn this one into an AP. He runs his first kilometer 3 minutes 45 seconds. The first kilometer is 3 minutes 45 seconds. His speeds drop steadily so that each kilometer takes him 12 seconds more than the preceding one. So D is 12 seconds. And this is A. The time taken to cover the first 12 kilometers is S of 12 is equal to n over 2 into 2a plus n minus 1d. N over 2 is 12 over 2, which is 6, into 2a, 3 minutes. I'm going to convert this whole thing to seconds, yes? 3 by 60 plus the 45, 225 seconds. 225 plus n minus 1, which is 11 by 12. 6 into 2 into 225 plus 11 into 12 close bracket 3492. I divided that by 60 to turn it to minutes. 58.2 minutes. And 0.2 of a minute is 0.2 by 60. Right, 12 seconds. So there's 58 minutes, 12 seconds. A. The lines that and that intersect at the point P, where P is equal to, one, you can solve them simultaneously, or you can just check each of these points into the equations if you wanted to. It's easy to solve them simultaneously, but we could just take the easier approach. I substitute in 5 and 10, so I get there's my x and there's my y's. So for the first equation, I have 7x, take away 4y, 7x take away 4y plus 25 supposed to be 0? No. So A is not a part of the answer. So again, I change my x and my y value. I check in this number 2. Minus 1 is my x. And 8 is my y. I get minus 14. Not the answer. I go in again. I get minus 9 is my x. And minus 32 is my y. I get 90. So that is not the answer. So the answer had to be the last one. But I still want to double check it. Delete 22. I get 0 as my answer. So D is the answer. If you wanted to solve them simultaneously, you'll big up yourself. The line through the points P and Q is parallel to the line with the equation that the value of K is. Okay, this is a nice question. Just rearrange this a little bit here, so bring that down there. Just partition off all of the working. So if P is K comma 2 and Q is 6 comma 8, and let's say that this line is parallel to 3x plus y minus 21 is equal to 0. Parallel lines have the same gradient. Rearrange this. Y is equal to minus 3x plus 21. The gradient of this line here is minus 3. So the gradient of PQ is supposed to be minus 3 as well. x1, y1, x2, y2. The gradient is y2 minus y1 over x2 minus x1, and that is equal to negative 3. 8 minus 2 is 6, is minus 3 into 6 minus k. 6 is minus 18 plus 3k. Minus 18 go across, we get 24 is equal to 3k, and k is equal to 8. See. Three now. The point that is at one end of a diameter of a circle whose equation is that the coordinates of the other end of the diameter are, alright, so if I know the center of the circle is the middle of a diameter. If I have a point, I will use my midpoint formula and get the coordinates at the next end. So let me figure out what the coordinates of the center of the circle is here. So we have x squared plus y squared minus 2fx. Actually, let me put it in the power form. X squared minus 2fx plus y squared minus 2gy plus c is equal to 0. Now, some of you all would have learned this formula with a plus here and a plus here. If you learned it like that, then by all means use that that particular form, but I like to use this form here because it's easier to read off the center, in my opinion. So x squared take away 2 fx plus y squared take away 2 gy plus c is equal to 0. I'm only concerned with the f and the g. So in order to get back minus 10, I need to have a 5 here. And in order to get back positive 2, I need to have a minus 1 here. So the center is 5 minus 1. That will be the center of the line. So we have 5 minus 1 is the center. And let me say, let me call that the midpoint one time now for your working. Let me say A is 2, 3. The midpoint, and B is the next point. Let's say XY is B. So the midpoint of AB is x1 plus x2 over 2, comma, y1 plus y2 over 2. This is my x1, my y1, x2, my y2. X1 plus x2 over 2 and y1 plus y2 over 2 is 5 minus 1. Equate each corresponding component. 5 is 2 plus x over 2. 5 2s are 10. 10 minus 2 is 8. Next, minus 1 is equal to 3 plus y over 2. Minus 1 by 2 is minus 2. Minus 2 plus 3 is 1. So 8 1 is the answer. Minus 2 minus 3, sorry. Minus 2 minus 3 is minus 5. My bad. D is the answer. A vector is given that a unit vector parallel to that is given as, this is a Pythagorean triplet, 5 12. The size of the vector, let me say the vector is AB. A is 5i plus 12j. Modulus of A will be 13. And the unit vector in the direction of A, u hat, is A over mod A, which is 1 over 13 multiplied by 5i plus 12j. C. OA is that, OB is that, AB is AO plus OB. We do not have AO, so AO is the same as negative OA plus OB. Negative OA is minus 1725. And OB is 45. This could be 17 plus 4 and minus 25 plus 5. 17 and 4 is 21 minus 20. 21 minus 20, D. The position vector of A and B relative to an origin. The acute angle AOB is given by, alright, so we have A dot B is mod A mod B cosine theta. So A dot B, if A is 2 5 and B is 3 minus 1, dot my i's, 3 2's are 6, add them to the product of the j's. 5 by minus 1 is minus 5, so I get 6 plus 5 is 1, is equal to mod A, that could be 5 squared plus 2 squared, that would be 25 plus 4, that is 29. Mod B is 10 cosine theta, move it across, 1 over root 290 is cosine theta. Theta is cosine inverse of 1 over root 290. 1 over root 290. If sine A is 5 113 and theta is obtuse, then tan theta is, let me draw a right angle triangle here. Jesus Christ. We could rock with that one. Sine theta is opposite over hypotenuse. Pythagorean triplet again. This fella is 12. Tan theta is equal to opposite over adjacent, which is 5 over 12. And it did say that theta is obtuse, so theta is here. Old school. Sine alone is positive here, so tan is negative. Tan is negative 5 on 12. B. Cos A plus B plus cos A minus B is equal to, alright, compound angle formula. That will be cos A cos B minus sine A sine B plus cos A cos B plus sine A sine B. U goes out with U. 2 cos A cos B. D. the graph of sine 2x is, well, sine 2x means that it completes one revolution in half the period. So one revolution will be completed in pi radians. So A is the answer. The smallest positive angle for which the equation that is, if I have sine theta minus cosine theta is equal to 0, sine theta is equal to cosine theta, divide by cosine theta, sine theta on cosine theta is equal to 1, tan theta is 1, theta is tan inverse of 1, which is pi on 4. 45 degrees. Number 31 now. Sine of that is equal to, again there's a compound angle formula, and luckily you just get compound angle formulas in your exam. Sine of alpha plus 45 degrees, that is sine alpha cosine 45 plus cosine alpha sine 45. There is sine alpha by 1 on root 2 plus cosine alpha by 1 on root 2. Factorize the 1 on root 2, we get sine alpha plus cos alpha. 1 on root 2 sine alpha plus cos alpha A. Convert 4.5 degrees to radians. 4 pi over 5, we need to multiply by 180 over pi. U goes into u here. What is that? 5 into 18 is 3. Remainder 3. 36 by 4 as well. I always check it over. 144 B. The exact value of tan of 150 is given by, well, we could make your life easy. Tan of 150 is, it's a negative number, so it can either be A or C. I want to check what A is. I'm looking for 0.577. 1 divided by root 3. I'm looking for 0.577. Cool. So A is the answer. You can check it over again. Root 3 is 1.7. So it can be negative root 3. Negative root 3 could be negative 1.7. Alright, the trigonometrical expression is identical to, well, this is a kind of a proof. Sine x over 1 minus cosine x plus sine x over 1 plus cosine x. Cross multiply. I'll get sine x into 1 plus cos x plus sine x into 1 minus cos x all over, Jesus Christ, there's a difference of 2 squares, so I get 1 squared minus cos x squared. I get sine x plus sine x cos x plus sine x minus sine x cos x. U goes out with u. I get 2 sine x on top. All over, I'll put it all over here, right? That is 1 minus cos squared x. 1 minus cos squared x is sine squared x. U cancel 1 of u. I'll get 2 over sine x. C. Given that y is equal to so by so, dy dx is, we could use the shortcut 3 chain rule here. 5 minus 2x to the power 5. So So dy dx is 5 into 5 minus 2x to the power 4 multiplied by the differential of the bracket, which is minus 2, minus 10 into 5 minus 2x to the power 4. Now A, the gradient at x is equal to pi on 6 on the curve y is equal to sine x is, calculus again, if y is sine x, dy dx is equal to cosine x, at x is equal to pi on 4 cosine of pi on 4, that is cosine of 45 degrees, that is 1 on root 2. Or pi on 6, sorry. Pi on 6 is 30 degrees, and cosine of 30 degrees is a half. Check it over. Cosine of 30 degrees is root 3 on 2. D. (37) The equation of the curve is given by that. The gradient function is given by, this is a straightforward product rule. Y is equal to x squared plus 2 into x minus 1 cubed. U is x squared plus 2. Du is 2x. V is x minus 1 cubed. dv is 3 into x minus 1 squared multiplied by 1. dy dx is v du dx plus u dv dx. Multiply it out. 2x into x minus 1 cubed plus 3 into x minus 1 squared into x squared plus 2. Factorize. I will have x minus 1 squared into 2x into x minus 1 plus 3 into x squared plus 2. This could be 2x squared plus 3x squared, I 5x squared. So it could either be C or D. And we have minus 2x. No more x's, so I need looking for a minus 2x. So the answer is C. And didn't even have to work out the last two. So where you can see to cut corners in a multiple choice, just cut the corner now. I didn't have to work out the whole thing to get the answer. Y is equal to 5 sine of 2x. Then dy dx is equal to 5 cosine 2x multiplied by the differential of the bracket, which is 2, which is 10 cosine of 2x. D. Curve is given by the equation that the second derivative, okay, so y is x squared plus 16x to the minus 1. dy dx is 2x take away 16x to the minus 2. And d2y over dx squared is 2 plus 16x to the minus 3, which is 2 plus 16 over x cubed. D. The value of a for which so by so is equal to 50 over 3. A and 0 of x squared minus 5 dx is 50 over 3. We integrate it now. I get x cubed over 3. Take away 5x. Evaluated between a and 0. Supposed to be 50 over 3. Substitute my upper limit. I get a cubed over 3 minus 5a. The next term will be 0 is 50 over 3. Just go to another polynomial, but what you could do, just double check it now. Check and see which one will get the answer. When a is 3, I check when A is 5, sorry, when A is 5, I check my answer. I'll get 5 cubed over 3. Take away 5 into 5. 50 over 3. So the answer is A. Last set of questions here. Last hurrah. For number 20. You know what number 29, Shane, boy? Or 39, sorry. Number 39. And I'm supposed to multiply by the minus 2 first. Numero 39, that was this one here. The calculus question. Where did I do that? Here. 2x minus 16x to the minus 2. Oh yeah, I don't multiply by 2. Oh, shucks. My bad. This could be plus 16 by 2 is 32. X to the minus 3. 2 plus 32, x to the minus 3. B. Alright. Thank you, Shane. Number 41, the integral of that is, again we can use the shortcut to the chain rule here. It will be 3x minus 5 to the power of 5 over 5, and I'm multiplying by the differential of the brackets on the denominator. We get 3. So 3x minus 5 to the power of 5 all over 15 plus my constant, in this case is k. To the power of 5 all over 15. C. The region in the first quadrant enclosed by the curve, the lines, is rotated about the x-axis. So volume is the integral of pi y squared dx between the limits a and b. Limit that will be the integral between x is 0 and 2 of y squared. I'll put any pi on the outside. Y squared will be x minus 1/2 x squared all squared. Yes. Right, dx, I want to fix this brackets here. So x minus x squared on 2. That is 1/2 x squared to be squared. Make life easy for myself now. Bring this to a common fraction, like 2x minus x squared all over 2 to be squared. Square it up, square it below. I'll get 4x squared. That will be x cubed, 2x cubed minus 4x cubed plus x to the power of 4 all over 2. That will be 2x squared minus 2x cubed plus 1/2 x to the power of 4. Alright, let me go ahead and integrate that. Pi, pi into 2x cubed over 3 minus 2x to the power of 4 over 4 plus x to the power of 5 over 2 into 5. Evaluate it between 2 and 0. Plug in the elements one time. Pi into 2 into 2 cubed over 3 minus, you go with you, 2 to the power of 4 over 2 plus 2 to the power of 5 over 10. Take away pi into 0 because the next one will work out to be 0. Let me see what this is here. 8 2s are 16 over 3. Take away, that will be 16 over 2 is 8 plus 2 to the power of 5 is 32 over 10 8 over 5, 8 over 15, pi. We have no 8 over 15, 16 over 3. Take away 8 plus 2 to the power 5 is 32 over 10. Right. May I make a mistake? Multiply these two here. 2x by x squared is 2x cubed, double it, 4x cubed, plus 4x to the power 4, 4x squared. Yeah. May I make a mistake? Let me just double check that one now. Right, let me just double check it. 2 into 2 cubed over 3, take away 2 to the power 4 over 2 plus 2 to the power 5 over 10. 8 on 15 pi. Take away 0 is 8 on 15 pi. Right, I will come back to this one. I don't want to waste too much time. 8 on 15 pi looking at the answer. Unless I make some kind of obvious mistake here. X cubed on 3 right, 2x cubed on 3 minus 2x to the power 4 over 4 plus x to the power 5 over 5 by 2. Yeah, right, unless I make some kind of big mistake. Right, I'll check it over. The region R enclosed by the x-axis, the curve, the lines, the area. So you have to integrate onto the curve. So it will be the integral between the lines x is 2 and 3 of x squared plus 2x minus 1 dx, x cubed over 3 plus 2x squared over 2 minus x evaluated between 3 and 2, 3 cubed over 3 plus, let's cancel a 2, 3 squared, take away 3, take away 2 cubed over 3 plus 2 squared, take away 2, (3 to the power 3 divided by 3 and 9. 9 plus 9 is 18. 18 minus 3, I like to double check it, you know. I think it's 15. So this first thing is 15. Take away 2 to the power 3 is 8. So I have 8 over 3 plus 4 minus 2. 4 and 2/3, 15. Take away the answer. 10 and a third, bring it down to a fraction. 31 on 3, 31 on 3. Integral of sine x plus 2 cosine x dx. I like to write if y sine x, then dy dx is cos x. So if I integrate cos x, I'll get back sine x. If y is cos x, dy is minus sine x. So if I integrate sine x, I get negative cos x. So this could be negative cosine x. And I integrate cos, I get sine plus 2 sine x plus c. So 2 sine x minus cosine x plus c. A. Given that the differential of that is that, then okay. So the differential of x over 1 plus x is equal to 1 over 1 plus x all squared. I want to know if I differentiating this fella here to get u, then if I integrate 1 over 1 plus x all squared, I will get back x over 1 plus x. So the question has the integral of 3 over 1 plus x squared, which is 3 the integral of 1 over 1 plus x squared dx. So this could be 3 into x over 1 plus x. Evaluated between the limits 2 and 0. I'm going to plug in 2 here. 2 over 1 plus 2. Take away 0. So 1 and 2 is 3. The answer is 2. Alright. So there's a whole paper one day. As usual, go back and look through the video and thing. Get answers. Taking a little 10 minutes there. And jumping back out with paper 2, 2012. So I'll go put it in the chat there. So paper 2 at 4:30 for anybody who reached late. Alright, in the meantime, I'm gonna see if I can fix up this camera again here. So organize. Alright guys, so you ready for the paper 2? No. Just nice. You know why the camera given so much of trouble now? Let's see if I could add it back again there. Nah, they're working. Alright. Paper 2. Again, well, this one I am going on bother to bring it in the mix. Well, I should have all the paper 2s. So we're starting with a little 2012. Now I think the structure of this exam going to remain the same when it comes to sections. Section 1, Section 2, answer 1 and Section 2. I would recommend we just look up the kinematics question. If anybody wants me to do the probability and statistics, just say so in the chat. I will do the probability and statistics. That is no problem at all. But for now, I'll leave you know that. Me, I want to waste time. Alright. So as I am doing these questions, I will be explaining them. Right, we're using GeoGebra here for, I will say, the majority of questions. Right, GeoGebra, top of the line up. Can't go wrong with it. Go download it, use it, real good, real good. So number 1, the functions f and g are defined by f of x is equal to x cubed plus 1. And g of x is equal to x plus 5. Now each one of these functions has a domain attached to it. 0 is less than or equal to x is less than or equal to 3, and this one is x is an element of the real numbers r. Part 1. This is 1a, part 1. Determine the composite function f g of x, or g f of x, sorry. G f of x is equal to g of x cubed plus 1, which is x cubed plus 1 plus 5, which is x cubed plus 6. State the range of g f of x. Part 2. Range is with respect to the with respect to the y-axis. So if I come here and I draw this function, I'm going to draw the function x cubed plus 6, x cubed plus 6. This how this fella does look. Now remember, I'm going to draw x cubed plus 1 now. X cubed plus 1. The blue graph has a domain between 0 and 3. So between 0 and 3, that is where this graph existing. This piece of the graph here, we're not considering it because of the domain given. So if I want to calculate the range of the graph, I need to figure out where on my y-axis does the graph exist. Now luckily I have a diagram here, but for calculations all I have to do in most cases, substitute the lowest value, substitute the highest value, and you will get the range of the values. Now I will give the range in this case here as a range of numbers. Sometimes range is also referred to as the highest value take away the lowest value, and that will be the range of a function. If a minimum or maximum point occurs within the domain, then that affects the range, and hopefully we will see a question where it affects the range. So the range of g f of x is equal to, when this is for 0 is less than or equal to x is less than or equal to 3, is g f of 0 is less than or equal to g f of x is less than or equal to g f of 3, and that the 0 is less than or equal to g of x is, no, 6, sorry, less than or equal to g of x is less than or equal to 3 3s are 9 3s are 27 plus 6 is 35. And like I said, in some cases you will actually get the range. People will calculate the range as the highest value take away the lowest value. Determine the inverse of g f of x. Well, let y be equal to the function, which is x cubed plus 6. Interchange x and y. I get x is equal to y cubed plus 6. Solve for y. X minus 6 is y cubed, and y is the cube root of x minus 6. So the inverse of g f of x, which is g inverse f of x, is equal to the cube root of x minus 6. Part B. I'm actually pull this here, so I want to see if anybody asking any questions. I see Shane say he wants to see a little probability. Shane, you gonna do that probability question in your exam, boy? X plus 2 is a factor of f of x. F of x is equal to 2x cubed minus 3x squared minus 4x plus a x. If x plus 2 is a factor, so f of x over x plus 2 is f of minus 2, and this is equal to 0. We quote the remainder factor theorem. If any polynomial f of x is divided by x minus a, then the remainder is f of a. If f of a is a factor, if f of a is equal to 0, then x minus a is a factor of f of x. Yeah, Shane, you have a choice. You always have a choice. Look at your past paper. Section 2. I'll read the instructions. Section 4, sorry. Answer only one question. Read it and see. Calculate what f of minus 2 is. 2 into minus 2 cubed minus 3 into minus 2 squared minus 4 into minus 2 plus a. This is equal to, jump on the calculator, 2 into minus 2 squared, bracket a squared, cube, sorry. Take away 3 into minus 2 squared minus 4 into minus 2 minus 20 plus a. We let f of minus 2 equal 0, so minus 20 plus a is equal to 0, and a is equal to 20. Part C. You could say therefore f of x is equal to 2x cubed minus 3x squared minus 4x plus 20. Part C. Solve the equation so by so is equal to so by so. That's 3 to the power 2x yeah, 3 to the power 2x. I hope all you have all the past papers following, huh? Take away 9 into 3 to the minus 2x is equal to 8. Can't bring them to indices. Can't introduce our logs, so we had to make some form of a substitution. So 3 to the power 2x minus 9 into 3 to the power minus 2x yeah, I could put that below. Alright, so 3 to the power 2x minus 9 over 3 to the power 2x is equal to 8. Let y be equal to 3 to the power 2x. So I have y minus 9 over y is equal to 8. If I multiply throughout by y, I get y squared take away 9 is 8y. Y squared minus 8y minus 9 is equal to 0. Factorize this up, we will get minus 9 and 1, y squared minus 9y plus y minus 9 is equal to 0. Y into y minus 9 plus 1 into y minus 9 is equal to 0. Y minus 9 into y plus 1 is 0. Y is equal to 9, or y is equal to minus 1. Recall that y is equal to 3 to the power 2x. So I have 9 is equal to 3 to the power 2x. I have 3 squared is 3 to the power 2x. Bases are equal, or the bases are the same. Equate powers. So I get here 2x, 2 is equal to 2x, and x is equal to 1. The next solution is minus 1, is 3 to the power 2x. Can't bring them to the same thing, so we introduce a log. So we take, I like to take ln. If you want to take lg, you could take lg. Take ln, so ln of minus 1 is ln of 3 to the power 2x, and ln of minus 1 is, you can say, not possible. So therefore, x is equal to 1 is the only solution to this question. Part D. Express x cubed is equal to 10 to the power x minus 3 in the form x cubed is equal to 10 to the, that 10 kind of weird there, boy. 10 to the power x minus 3 in the form so by so. So we need to introduce a log. This is log to base 10 we want to make it look like, so we had to introduce log to base 10. So we take log to base 10 on both sides. I get log of x cubed to base 10 is log of 10 to the power x minus 3 to base 10. As I use our law in logs, I recall the law in logs. I see in the law to bring the power in front. Log of a to the power c to base b, and the law works both ways, is c log of a to base b. And I also see in log of a to base a is equal to 1. So again, 3 log of x to base 10 is x minus 3 log of 10 to base 10. So 3 log of x to base 10 is x minus 3. Now what do I want log of x to base 10 alone? So we divide through by 3. Log of x to base 10 is 1/3 x, take away 1. And we say is of the form log of x to base 10 is equal to ax plus b, where a is 1/3 and b is minus 1. Cool. This is D part 1. We will do D part 2 up here. State the value of the gradient of a graph log of x to base 10 versus log of x. Alright, now just a quick thing. You see how in GeoGebra here, right? We have the x-axis and the y-axis. Now, these axes are directly related to our equations. So let me just say, right? Just bring this down a little bit here. Let me just say, I had an equation that says v is equal to 2w plus 6, and I want to draw this, represent this equation on a graph. My axes, yes, I will have a vertical and a horizontal axis, but my axes will be v versus w, just like how we have y is equal to mx plus c, and my axes are y and x, because this y corresponds to the variable in the equation and this x corresponds to this variable in the equation. So if I have log of 10, well, log of x to base 10, sorry, I can't even undo that there. If I have log of x to base 10 is equal to 1/3 x minus 1. When I draw my graph for this axis here will be log of x to base 10, and this axis here will be x. It will be on the form of a straight line where this is a variable, this is a constant, this is a variable, this is a constant, just like y is mx plus c, and the coefficient of x is usually the gradient. So what we say that how log of x to base 10 is 1/3 x minus 1 is of the form y is equal to mx plus c, for those of you who are comfortable with conversion to linear form, where m is a gradient is equal to 1/3. You don't need to say where C is the y-intercept because all it asks for is the gradient of the graph. And you're good to go. Next. Number 2. Part A. The quadratic equation x squared minus 4x plus 6 is equal to 0. X squared minus 4x plus 6 is equal to 0 has roots alpha and beta. Alpha and beta roots, I like to state what A is, what B is, and what C is. I know that how the sum of the roots, alpha plus beta, is minus B on A, which is minus 4 over 1, which is 4. And alpha beta is equal to C over A, which is equal to 6 over 1, which is equal to 6. Now, they want calculate the value of alpha squared plus beta squared. So we need to manipulate the roots, alpha squared plus beta squared, and see what we get. That's not, right. So alpha squared plus beta squared. This is something that you're going to learn. If you want to proof it, ask for the proof of it. Is alpha plus beta all squared minus 2 alpha beta. In the exam, you don't need to show the proof. You can code this here and you'll be good to go. Alpha plus beta is 4 minus 2 alpha beta is 16 minus 12, that is equal to 4. Part B. Find the range of values of x for which so by so is greater than 0. Right? So this is a question like we did in the multiple choice just now. 2x minus 5 over 3x plus 1 is greater than 0. And again, if anyone wants a further explanation for how we doing the calculations for this, just ask and I will make a separate video and put it up on YouTube, probably tonight itself. So first things first, I'm multiplying by 3x plus 1 all squared. So I have 2x minus 5 into 3x plus 1 squared over 3x plus 1 is greater than 0. You cancel with u on top, so I end up with 2x minus 5 into 3x plus 1 is greater than 0. I'm going to let 2x minus 5 into 3x plus 1 be equal to 0 and then solve. 2x minus 5 is equal to 0, x is equal to 5 over 2. Or 3x plus 1 is equal to 0 and x is equal to negative a third. I'm going to represent these two solutions on a number line. I'll do it up here. My two solutions are minus a third and 5 over 2. Again, I'm going to let the number line be so by so, but this is section 1, this is section 2, and this is section 3. Section 1, x is less than minus a third. In section 2, this part is x is greater than minus a third. In this part here, x is less than 5 over 2, and x is greater than 5 over 2. I'm just going to combine the two ranges in section 2 to get minus a third is less than x is less than 5 over 2. If you all need an explanation on that, again, let me know. I'll make the video. Every single time I'll test x is equal to 0 in the inequality. So we have when x is equal to 0 in the inequality, I will have minus 5. I will write it down, 2 into 0 minus 5 over 3 into 0 plus 1 supposed to be greater than 0. I get minus 5 is greater than 0. This is true. So therefore, x is equal to 0 satisfies the inequality. Zero is in section 2. Write that a little better. 0 is in section 2. Therefore, the solution will be x is such that x minus 1/3, sorry, minus 1/3 is less than x is less than 5/2. That's it. Part C. A customer repays a loan monthly by increasing the payment each month by X dollars. If the customer repaid $50 in the 5th month and $70, okay, this is an AP. A customer repays a loan monthly by increasing the payment each month by X dollars. So my common difference D will be X dollars. If the customer repaid $50 in the 5th month, so the 5th month we can represent it as T5, he repaid $50. Make that 50 a little better. And $70 in the 9th month, T9 is equal to 70. Calculate the total amount of money repaid at the end of the 24th month, right? Tn is equal to A plus n minus 1 D. T5 is equal to A plus 4D, and T7 is equal to A plus 6D. They say that our T5 is equal to 50, so I will just put this is equal to 50, and I'll put this is equal to 70. In this case, D is X. So I can work out what X is. If I have T5 take away T7, just like when we did the multiple choice for GPs, a trick we can use is to divide the terms in a GP. A trick we can use in APs is to just subtract the terms. If I subtract both terms, I will end up with A plus 4x take away A plus 6x is equal to 50 take away 70. The a's cancel. 4x minus 6x is minus 2x is equal to minus 20, and x is equal to 10. So each month, brother man, he increasing his payment by X dollars. So we can find out what the first month is. Well, that will be T sub 1, which is equal to, oh, we need to figure out what A is. I paid $50 in the 5th month. Alright. First term is A. So A is equal to, well, I don't know, you can substitute back X into the equation. When X is 10, we go have a plus 4 into 10 is equal to 50, and a is equal to 50 minus 40, which is also equal to $10. So a is 10 and x is 10, and it kind of making sense, because if you watch back the question, if he increasing his payment by x dollars in the first month, in month 1 he will have x. Let me say month 1 he had $10. In month 2 he will increase it by 10, 20. Month 3, 40. 5, 4, 50. The 5th month he will have $60. 50 minus 40 is 10. 70 minus 60 is 10. If he increasing 10 by $10, so if he paying back $10 in the first month, he increases the payment by $10. So in the second month he will be paying 20. In the 5th month he paying $70. 5th month he paying $50. Customer paid $50 in the 5th month. Here again, $60 in the 5th month. Oh shucks, 30. 40, yeah, and 50. So good. We're going good so far. They want to know the total amount of money we paid at the end of the 24th month. So the total amount of money. So it's not the 24th term. It's not the money he paying in the 24th month. It's the total number of money he paying in the all 24 months, which will be S24, which will be n over 2 into 2a plus n minus 1 by d. N over 2, 24 over 2 is 12, into 2 into 10, plus 11 by 10. Jump on the calculator. 12 into 20 plus 110, 1560. Cool. Yes, Shane, simultaneous equation self. That is thing self we're dealing with here. Just give me a sec. Right. The equation of a circle is given by, this is number 3, part A. The equation of a circle is given by x squared plus y squared, okay, plus da 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 da. A line has equation so by so. Show that this line passes through the center of the circle. Okay, so first we need to figure out what is the center of the circle, and then I'll check that point in the equation and see if it satisfies the equation of the straight line. So we have x squared minus 4x plus y squared plus 6y minus 87 is equal to 0. So one time I'm gonna try and rearrange this in the general form for the equation of a circle. X squared minus 2fx plus y squared minus 2gy minus 87 is equal to 0. In order to get back minus 4 on top, I need to put a 2 here. In order to get 6 on top, I need to put a minus 3 here. And I say is of the form. Again, if you learn the equation, the general equation with a plus here and a plus here, no problem. Is of the form x squared minus 2fx plus y squared minus 2gy plus c is equal to 0, where I'm only concerned with the center, where fg, which is equal to 2 minus 3, is the center. So substitute the values of 2 minus 3, where this is my x and this is my y, into, this is part 1, into x plus y plus 1 is equal to 0. So we get x plus y plus 1 is equal to 0. 2 minus 3 plus 1 is equal to 0. 2 minus 3 is minus 1. Minus 1 plus 1 is 0. 0 is equal to 0. Therefore, the point 2 minus 3, therefore the equation passes through the center. The equation x plus y plus 1 passes THROU passes through the center. Cool. I'll do part 2 up here. Please, not too much working. Find the equation of the tangent to the circle at the point A, which is negative 6, 3. Okay, cool. So A is minus 6, 3. I'm going to let C be the center of the circle, which is 2 minus 3, and let XY be the tangent at A. Here we have to calculate the gradient of the radius. The gradient of AC is y2 minus y1 over x2 minus x1. What we can do, we can say that AC is a radius. Gradient of AC, we will have x1 y1 and x2 y2, y2 minus y1 over x2 minus x1. Minus 3 minus 3 is minus 6. 2 plus 6 is 8. I get minus 3/4. The gradient of AC multiplied by the gradient of xy is equal to minus 1, because the product of the gradient of perpendicular lines is equal to minus 1. This statement is very, very important. You go get your marks for your statement. So I want to calculate the gradient of xy. The gradient of xy is minus 1 over the gradient of AC. That is minus 1 divided by minus 3/4, which is minus 1 multiplied by minus 4 over 3, which is 4 over 3. It doesn't matter where the minus sign goes on a fraction. It could go on the numerator, denominator, or in front the whole fraction. Now it's time to calculate the equation. The equation of xy, and I'm going to state using the point A, which is a point on the line. This becomes my x1, y1. y minus y1 is m into x minus x1 y minus y1 is 4 over 3 into x minus x1. So one time I'm going to expand the brackets and move the negative 3 across. So y is equal to 4 over 3x. That will become a plus 4 over 3 multiplied by 6. 4 over 3 multiplied by 6 is 8 plus 8. The 3 goes across, becomes plus 3. So y is equal to 4 over 3x plus 11. And always state is of the form y is equal to mx plus c, where m is the gradient, which is equal to 4 over 3, and c is my y-intercept, which is equal to 11. And we got to go. Part B. Just now. Right. Sorry about that. I gotta check my message and thing now. Part B. Given that OA is A, alright, people say that OA is equal to A, and OB is equal to B, AP is a half OA. Okay. Is a half OA, right? So PA will be a P. AP is 1/2 of OA. So PO is a half of, is the next half of OA. Okay, cool. Where A is equal to 2, 1, and B is equal to 3, 2. Write BP in terms of A and B. Okay, so BP is B something plus something P. What common between B and P? That will be A. BA will be negative AB. So I come in my working column here one time, and I calculate what AB is. AB is AO plus OA, sorry, OB we do have AO, so this is negative OA plus OB minus A plus B, and BA is negative AB, which will be A minus B. So BA is A minus B, and AP is a half OA, which is equal to a half of A. So we get a half A plus A, that is 3 over 2A minus B. Right, and they did say in terms of A and B. And find the size of BP. Alright, so this is part 1. This is part 2. The size of BP. I need to figure out the numbers that go in here. So we have 3 over 2 multiplied by the vector A, which is 2, 1. Take away the vector B, which is 3, 2. So this becomes 3 over 2 multiplied by 2. That will be 3. 3 over 2. Take away 3 and 2. 3 minus 3 is 0. 3 over 2 take away 2 is, check and see, 3 over 2 take away 2 is equal to negative a half. So the size of BP is the square root of 0 squared plus minus a half squared, which is equal to the square root of a quarter, which is equal to 1/2 units. Not bad for 3 marks. Alright, number 4. The topic that has given people plenty problems. Tricks. Supposed to be the easiest topic in the book, man. The diagram shows a sector of a circle, center O, with an adjoining square. Cool. The radius of the circle is 4 meters. Cool. If the sector AOC subtends an angle pi on 3 at O, cool, give your answer in terms of pi, the area of the shape. So the area of the whole shape then. So what I actually recommend is to just give the shape a quick redraw and label your shape accordingly. So let me just pretend that I redraw the shape here. When you're redrawing a shape, make sure and say let the shape be so by so, where this is A1 and this is A2. So the area of OACMN is equal to the area of A1 plus the area of A2. The area of A1 is a half r squared theta, a half 4 squared pi on 3. Jump on your calculator. A half of 16 is, what is that? 8. No, you don't have to jump on your calculator, man. 8 pi on 3 meters squared. Area of A2 is equal to, is a square, right? Let's say I join in square. Side squared, which is 4 squared. That is 16 meters squared. So the area of OACMN is equal to 8 pi over 3 plus 16 meters squared. If you want to simplify this and bring it to one common fraction, feel free to do so. You wouldn't lose no marks. That is part 4A, part 1. And part 2 is the perimeter. The perimeter of OACMN. Perimeter is distance around, so we just write along everything we have. OA plus AC plus CM plus MN plus NO. OA is 4, AC is r theta plus cm is 4 plus 4 plus 4. 1, 2, 3, 4. So that will be 16 plus r theta, which is 4 into pi on 3. So this could be 16 plus 4 pi over 3 meters. Again, if you want to leave it like this, you could leave it like this. If you want to find it in one fraction, you could go ahead and find it out in one fraction. Alright, part B. Alright, we will take a little 5 after this one, like a 5-minute break after this one. Tackle number 5, 6, and 7. Like I say, 5, 6, and 8. We're not doing the probability question. Given that sine of pi on 3 is root 3 on 2, cos of pi on 3 is a half. Sine of pi on 4 is cos of pi on 4. Which is equal to root 2 on 2. Evaluate without using a calculator the exact value of cosine of 7 pi on 12. So be cosine 7 pi over 12. Now, let me break it down a little bit here. Radians is something that is give you trouble to visualize because we're not really exposed to it as much as we are exposed to degrees. So this is what I want to do. If I ever get a question in terms of radians, try and do the question in terms of degrees. But when you're doing the question in terms of degrees, just do that for yourself. That is your own private little working. So we will put your own private little working in a box on this side here. CXC not seeing this. And for good reason. I want to know what 7 pi on 12 is. I multiply by 180 over pi. And how much I can see. 7 by 180 divided by 12, 105 degrees. So they're really asking us for cosine of 105 degrees. I want to know what pi on 3 is. Pi on 3 I know is 60 degrees. And I want to know what pi on 4 is. Pi on 4 is 45 degrees. So I know that 105 degrees is 60 degrees plus 45 degrees. So cosine of 7 pi over 12, which is 105 degrees, is cosine of 60 degrees plus 45 degrees. So I break up my angle into my compound angle formula. So this is equal to cosine of pi on 3 plus pi on 4. And from here, we can work in radians because we have all the information we need. We recall that cosine of A plus B is cosine of A cosine of B minus sine A sine B. So cosine of pi on 3 plus pi on 4 is equal to cosine of pi on 3 cosine of pi on 4 minus sine of pi on 3 sine of pi on 4. We know what cosine of pi on 3 based on the information given. Cos pi on 3 is a half. Cos pi on 4 is root 2 over 2. Minus sine pi on 3 is root 2 over 2. Root 3 on 2. And sine of pi on 4 is root 2 over 2. both of them will have a denominator of 4, so I can add both numerators together, and I get root 2 minus root 6 all over 4 in exact form. So cosine of 7 pi over 12 is equal to this. And we can double check it and see. Change your calculator into radians and calculate cosine of 7 pi divided by 12. If I take away root 2 minus root 6, root 6 all over 4, and put all this in a big bracket here, I suppose to get 0, because both of these things are the same thing. If you're more comfortable, cosine of 7 pi on 12 is negative 0.83333. Root 2, take away root 6, divided by 4, divided by 4. Oh shucks, is root 2. Didn't I put root 2? Root 2 minus root 6 divided by 4. Negative 0.25. Did I write it down wrong? Oh, I didn't put my brackets for the cosine, sorry. Cosine of 7 pi over 12 is negative 0.2588 tralalala, which is the same thing as the previous answer we got. As root 2 minus root 6 divided by 4. Negative 0.2588 tralalala. Right, so you could always double check these on your calculators. Identity time. The Achilles heel of most of you all. 1 over a big nasty fraction. 1 over cosine theta plus tan theta is equal to 1 minus sine theta over cosine theta. So this is required to prove, followed by reproof. We take the left hand side. Now just because it's looking nasty don't mean we had to work it out like how it's looking. Consider the denominator first, because I know most of my work going to be done on the denominator. Plus tan theta. If I recall, tan theta is sine theta over cosine theta. So 1 over cosine theta plus tan theta, it will be plus sine theta over cosine theta. The denominators are the same, so I add my numerators. 1 plus sine theta over cosine theta. So I get my denominator in the form of a fraction, 1 fraction. So we had 1 divided by my denominator, which is 1 plus sine theta over cosine theta. This is equal to 1 multiplied by cosine theta over 1 plus sine theta. So I end up at a stage here where I have cosine theta over 1 plus sine theta. But I want to get 1 minus sine theta over cosine theta. Now the minute you start to ratch is when you end up in problems, because you're seeing this fella here and he looking, sorry, not him, this fella here, and he looking real similar to the answer here. So you go make a question yourself, I wonder if I really had to flip this thing, boy. I wonder what's going on here. Just stick with your gut and keep trying something. One of the tricks in proving identities is multiplying by the number 1. Now the number 1 has an infinite number of forms. It could be x over x. It could be sine theta over sine theta. It could be sine squared theta over sine squared theta, and so on. So what I'm going to do, I'm going to multiply by the number 1 in a particular form. You can keep trying. If you try, let me see, it will make sense I'm multiplying by 1 in the form of tan theta over tan theta. That's not going to help us. I can multiply by sine theta over sine theta. I can multiply by cosine theta over cosine theta. But again, them things wouldn't help me to move forward in my question. However, if I multiply by cosine squared theta over cosine squared theta, something might happen. Now, I don't want people to start cancelling u with u1 and get cosine theta and below one thing as yet. Don't do that as yet, right? I want no cancelling going on as yet. This is equal to cos cube theta over cosine squared theta into 1 plus sine theta. Now, if you remember, cosine squared theta is something. That is one of your identities. Recall, cos squared theta, I'm going to put the whole thing, plus sine squared theta is equal to 1. Brother man, cos squared theta is 1 minus sine squared theta. Another way you could have do this is, actually an easier way we could have do this is to just rationalize the denominator, multiply by 1 minus sine theta over 1 minus sine theta. Yeah, we could do that too. I'll do that one as well afterwards, right? And you can see the variations we could get. So my fraction turns out to be cosine cube theta over 1 minus sine squared theta into 1 plus sine theta. I'm going to expand it below. Actually, you know what? This could be, it could take a chunk full to do this one. So let me just multiply by something else. I'm multiplying by 1 in the form of 1 minus sine theta over 1 minus sine theta. This could be cosine theta into 1 minus sine theta over, this fella here is a difference of 2 squares, so I get 1 squared minus sine theta squared. That is cosine theta into 1 minus sine theta all over 1 minus sine squared theta. We want to get 1 minus sine theta, 1 minus sine squared theta. If you recall, cosine squared theta plus sine squared theta is equal to 1. So sine squared theta, cosine squared theta, sorry, cos squared theta is 1 minus sine squared theta. So my denominator is reduced to 1 minus sine squared theta, 1 minus sine theta over 1 minus sine squared theta, and this is a difference of 2 squares, cosine theta into 1 minus sine theta. Sorry, what am I doing, boy? Again, a little tunnel vision there, sorry. Over cosine squared theta. You go cancel with one of you and you remain with cosine theta. 1 minus sine theta over cosine theta, which is equal to the right hand side, QED. Now please, 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 don't be ratcheting up the place. Right? I don't want nobody ratcheting up the place and trying to get a correct answer. I am making sense. Right? Alright, so let me take a little 5 minutes break there, and we jumping out with numbers 5, 6, and 8 in about 5 minutes. So at 5:45, that's when you come back. Alright guys, we're back. Alright, so I see Sammy say that just confirmed. Sammy, who you confirmed that with? I want to know if there's a credible source before we dive into the probability and statistics questions. I mean, if you had to do it, we had to do it, we have no problem. But I just want to confirm that source. Right, so in the meantime, let's continue. Number 6, differentiation. Number 5, sorry. Differentiate the following expression with respect to x, simplifying your answer. So first things first, I do have a y. So let y is equal to 3x plus 4 over x minus 2. Check the specimen paper on the CSEC. It have a specimen paper for 2020 or 2021. I checked that one time. Right, so just give me a second. I'm gonna check that one time. Link it in the chat there. No, me no e-tests. Link it in the chat. You know where you find that. I'm digging up here. I think I'll get in it. Still link it now, still link it. I go waste too much of time. Link it. When I link it, then we go organize it, right? Right, so we had to differentiate this fella here. Is of the form y is equal to u over v. U is equal to 3x plus 4 and du dx is equal to 3 and v is equal to x minus 2. dv dx is equal to 1. dy dx is equal to v du dx minus u dv dx all over v squared, and this is the quotient rule. V du dx minus u dv dx all over v squared. We could simplify the top. This is 3x minus 6 minus 3x minus 4 all over x minus 2 squared minus 10 over x minus 2 squared. And that's it. 5a, 5b. The point P, 2, 0 lies on the curve. Find the equations for the tangent to the curve at P. Alright. So y is equal to 3x squared plus 5x minus 12. Part 1. The tangent to the curve at P. We gotta get dy dx. Equation for the tangent. Okay, dy dx is equal to 6x plus 5 at x is equal to 2. Dy dx is equal to 6 into 2 plus 5. 12 and 5 is 17. This is the gradient of the tangent at P. Equation of the tangent at P. P has coordinates 210, x1, y1. It'll be y minus y1 is equal to m into x minus x1. So y minus 10 is 17 into x minus 2. Move across everything one time. 17x minus 34 plus 10. Y is equal to 17x minus 24 is of the form y is equal to mx plus c, where m is the gradient is equal to 17 and c is the y-intercept, which is equal to negative 24. Part 2, the equation for the normal at P. Rinse and repeat, just a different gradient. The gradient of the normal is minus 1 over the gradient of the tangent. Why, you might ask? Because the product of gradient of perpendicular lines is minus 1. Minus 1 over 17. So the equation of the normal at P, and P has coordinates 210. This could be my x1 and my y1. Could be y minus y1. We already read on the formula, so we don't have to write it down again. Y minus y1 is m into x minus x1. One time rearrange. Minus 1 over 17x plus 2 over 17 plus 10 minus 1 over 17x plus 2 over 17 plus 10 is 172 over 17. Of the form, tra-la-la-la. I just hit another quick copy and paste here. Where m is the gradient is minus 1 on 17. And this is 172 on 17. You saw Cohen Springer did a video talking about it. Alright, well I'll I'll not do the probability question tonight. I'll go and check the video and I will confirm that 100% with you guys. And tomorrow for class, if we have to do it, we will do the probability and statistics question from this paper tomorrow, and we'll do all the probability and statistics questions from there on out. Part C, rates of change. The length of the side of the square is increasing at a rate of 4 centimeters per second. Okay, let the length of the side of the square be S. So the S dt is 4 centimeters per second. Positive means it's an increase. Find the rate of increase of the area. Alright, so we know the area of a square is side squared. You can differentiate this and get the ADS is 2S. And we require to calculate the rate of change of area, which will be the ADT, when S is equal to 5 centimeters. Alright, well, the ADT using the chain rule is the AD something multiplied by the SDT, because those are the information we have from before. The chain rule, hit them a quick substitution inside of there. The ADS is 2S and the SDT is 4. So this is 8S centimeters squared per second. When S is equal to 5, the ADT is equal to 8 by 5, which is 40 centimeters per second. Alright, seen. Right, that's it for number 5. Number 6. Evaluate the integral between 2 and 1. Right, simple integration question. 16 minus 7x all cube dx. Right, a little substitution. Let t be 16 minus 7x dt dx is minus 7 and dx is equal to dt over minus 7. Okay, Sammy, big up yourself. Janice, this is 2012 paper 2. So this will become the integral between 2 and 1 of t cubed with respect to t over minus 7. Integrate, we get t4 over 4 multiplied by the minus 7, evaluated between 2 and 1. Now note, I change my limits because I have all intentions to change back t in terms of x. So this becomes t to the power 4 over minus 28, evaluated at 2 and 1. T was 16 minus 7x to the power 4 over minus 28, evaluated at 2 and 1. Substitute the limit 2, 16 minus 7 into 2 over 20 minus 28. Take away 16 minus 7 into 1 over minus 28. Check and see what we get. 16 take away, what is that, 14 divided by minus 28. Oh Jesus Christ, I have to leave it as a fraction, yes. 16 take away 7 to the 14 over negative 28. Why upon 11? 16 take away 14. Right, so we have minus 2 on 28. Minus 2 on 28. Take away 16. Take away 7 on 28. I'm going to put a nice big bracket over here now. Also, both of them going to be over 28. 11 over 28 minus 11 over 28. So that will be minus 2 plus, minus 2 plus 11. I'm going to calculate that math, yes. This is minus 2 over 28, and this fella becomes plus 16. 16 minus 7 is 11 over 28. Minus 2 plus 11 is 9 over 28. And that's supposed to be the answer there, 9 over 28. If I make a mistake, somebody had to let me know. But yeah, I think we got to go there. You're just double checking something here, right? Oh, look at that. Tell me I make the mistake, boy. I'm supposed to put this to the power 4, boy. Jesus Lord. Nobody tell me nothing, boy. Aged. Nobody looking out for me, boy. Nice small thing. So we have 2 to the power 4 over minus 28. Take away 16 minus 7, that was 9. Why I guess 16 minus 7 is 11 last time, boy. 9 to the power 4 over minus 28. Two to the power 4, 16. So we have negative 16 on 28 minus 4 on 7. Take away, well, this becomes plus now. 9 to the power 4 over 28. Two 33 and 3/4. Right? Be careful, eh? Right? Be careful. Alright, next question. The tiredness now kicking in there. Part B. The point Q lies on the curve for which dy dx is that the equation of the curve. Alright, so if I have dy dx is equal to 3x minus 5. If I integrate dy dx with respect to x, I will get back y. So y will be the integral of 3x minus 5 with respect to x. Y is 3x squared over 2 minus 5x plus c. Need to say where c is a constant. They say that our Q lies on the curve. Q, which has coordinates 4, 8, lies on the curve So this is my x and my y. So all I have to do is substitute my values for x and y into the equation to get the value of c. 8 is equal to 3 into 4 squared over 2 minus 5 into 4 plus c. 8 minus, what is that? 4 4s are 16. 16 divided by 2 is 8. 8 3s are 24. Plus 20 is equal to c. I like to double check on my calculator. 8 minus 24 plus 20 is 4. So c is equal to 4. So therefore, y is equal to 3x squared over 2 minus 5x plus 4. And part C could fit here. Calculate the area between the curve y is equal to 2 cos x plus 3 sin x and the x-axis from x is equal to 0 to pi on 3. Okay, cool. So it's bounded by the x-axis, it's bounded by the y-axis, and it's bounded by pi on 3. So the area between the curve will be the integral between pi on 3 and 0 of 2 cos x plus 3 sin x dx. I like to write this down here. If y is equal to cosine x, then dy dx is equal to sine x. So if I integrate sine x, I get back cosine x. If y is equal to sine x, sorry, dy dx is minus sine x. So when I integrate, I'm going back to the first one. When I integrate sine x, I get negative cos x. And when I integrate cos x, I get back sine x. So this will be 2. When I integrate cos x, I get back sine x. And when I integrate sine x, I get negative cosine x. Evaluated between pi on 3 and 0. Now for trigs, just because you have 0 as my lower limit doesn't mean that the second part of my substitution will work out to be 0, because cosine of 0 is a number. It's 1. So you just have to be careful. So let's substitute with limits now. So I get 2 sine of pi on 3, take away 3 cosine of pi on 3 minus 2 sine of 0 minus 3 cosine of 0. Sine of pi on 3, we're in radians already. Sine of pi on 3 is root 3 on 2. So this is 2 multiplied by root 3 on 2. Take away 3. And cosine of pi on 3 is supposed to be a half. A half. Take away sine of 0 is 0 minus 3 cosine of 0 is 1. You can double check that on your calculator as well. Sine of 0 is 0 and cosine of 0 is 1. So here we get this 2 cancel with this 2. I get root 3 take away 3 over 2 plus 3. I get root 3 minus 3 over 2 plus 3 is 3 over 2 plus 3 over 2. If you want to express it as a single fraction, you can go ahead and do so. They just say, oh, they said to calculate the area. So this will be square units in exact form. Easy little 3 marks there. Part D. Calculate the volume of a solid formed when the area enclosed by the curve, the x-axis. So we have rotation about the x-axis. So rotation about the x-axis, the volume will be the integral between a and b of pi y squared dx. Yeah, rotation on the x-axis is pi y squared. So we had to go on square y to get y squared there. We're going to square it and see what we get. So it could be the integral. The lower limit could be 0 and 3 of pi y squared is x squared plus 2 squared dx. I can bring the pi on the outside. Pi, the integral between 3 and 0, and I'm just going to square the brackets now. This will be x to the power 4 plus 4x squared plus 4 with respect to x. If you wanted to use the substitution method to integrate this here, you could have done so, no problem in that. Pi x to the power 515 plus 4x cubed on 3 plus 4x evaluated between 3 and 0. Substitute my upper limit. I get 3 to the power 5 over 5 plus 4 into 3 to the power 3 over 3 plus 4 into 3. Take away pi and just give it a quick look. Every term has a x and I'm substituting 0, so everything will reduce to 0 in the second bracket. I'm leaving my answer in terms of pi. 3 to the power 5 is 243 divided by 5. Okay, I'll leave it at that. 243 over 5 plus 3 to the power 3 multiplied by 4, 108 over 3 plus 12. And this is equal to 243 over 5 plus 108 over 3 plus 12 is 96 and 3/5. 96 and 3/5 pi cubic units. Alright, so I see somebody's here at all. Alright, you send it to me, Sammy. Let me see if I've seen it here. You send it to me, man.
Everybody messaging me already.
I see Jenny said that all this specimen paper is part of the syllabus. Right, let me just check over my syllabus here, right? I know the syllabus had changed. Let me just check over my syllabus here. The syllabus here. Let me see if I can see a specimen paper. through the question 1 in the specimen paper and paper 2. There is the section 4 in paper 2 and see what it is here. There is section 4. All working must be clearly shown. Let me see what the instructions is in the beginning. Okay, so it's 6 questions and I had to answer all questions. So it's no longer 8 questions. So it's 6 questions and we had to answer all. So I feel we could do this one tomorrow. We could do the specimen paper tomorrow. Number 4, I want to see if how to change up number 4. So number 4 is the differentiation question. Number 5 is integration and incorporate a little bit of kinematics in the integration. And number 6 is probability and statistics. That is last, so that is a whole question on probability and statistics. Yeah, and they just break up the kinematics question and bring it in piece of the calculus. Alright, no scene. Yeah man, that no scene. We go tackle that. Everybody, we go tackle that tomorrow. So here is seen everybody. We're gonna stop the live. Tomorrow, same time, same place, we're gonna finish out number 7 and number 8 in 2012. We will do the next. We will do the specimen paper 1 and paper 2 tomorrow as well. Alright. So go back and view the live if you have any questions running. And practice. Good luck in all the exams tomorrow for those of you who have exams tomorrow, and I'll see everyone tomorrow afternoon.